Hello, good morning. How is everyone? Let's wait for some time for everyone to join actually. Yes. Hi, if anyone is out there, please let me know how are you and how is everything going on? कैसे हो सभी? You can let me know in the chat box as well. I will keep on checking. So today we are primarily focusing on question solving, and through question solving, we will be revising our topics as well. We will be picking key concepts and noting it down. So should we start? Yes, it has already been 2 minutes past. So now I'm good to go. So let's get started actually. So here is the first question. Then before starting with the question, I want to say one thing that for every question, I will be giving you a certain amount of time, right? And in that certain amount of time, what you have to do is you have to read the question very carefully. Again, I'm saying don't think or don't presume before that, yeah, questions you won't be able to do or something like that. No, you have to read the question very carefully. And after that, you have to try solve the question. Okay? Even if it happens or not, that doesn't matter. How long you're staying with the question is actually important. Done. So initial 3 or 4 days is going to be struggle. Why struggle? Because you are not quite accustomed with solving such questions. And if you have solved earlier, that's a good. If you have not, again, nothing to worry about. We have to be patient throughout the session and we have to keep on reading questions carefully and solve. So without wasting any further time, let's start with the very first question. Done. So this is your first question on the screen. I hope you all can see it now. So what I want you is, please solve the question carefully. Please read the question carefully. Done. Yes. So read the question carefully and do it. I'm giving you 2 minutes of time. I won't be speaking much, Kyuki. I have given you this time. Use it properly, read the question, solve it. Done. So you must have read the question carefully. Now let's do it together. So what the question is, in the question it is given that there is a there is a neutral conducting sphere. Again, give focus on the question statement. A neutral conducting sphere. This is a conducting sphere, right? A positive point charge is placed outside the sphere. So let's take this sphere like this. And what is happening? A positive point charge is placed outside the capacitor. So suppose this is positive point charge and this is kept outside the sphere. The net charge on the sphere is then. So sphere पे net charge क्या होगा? This is the question. So what is going to happen? If you recall induction properly, in induction also the same thing was happening. We were taking a positive charge thing near a neutral conducting sphere, and then charge were getting induced like that. So the same thing is here. So what will happen, since this is a positive charge and this is a neutral conducting sphere, so this is a conductor, it means it will have free charges. What will happen? It will, this positive charge will attract negative charge towards itself, and it will repel positive charge away from it. So positive charge is going to get distributed like this. Okay? So such kind of distribution is going to happen. But the thing is, this was neutral. Done. So overall, what is going to happen? This was initially neutral. Finally, what is happening? A positive charge is coming just in front of it or in its vicinity. So because of this positive charge, such kind of configuration will happen, right? But overall charge on the conducting sphere will remain what? Same. It will remain zero. Initially it was zero. Finally it will remain zero. Also, we have studied one thing, that if any system is isolated system meaning in current electricity and electrostat is what? In electrostat or in current electricity, if it is given that system is isolated, it means it is not connected with any battery. And if anything is not connected with battery, then its charge will remain conserved. It means if it initially it has zero charge, finally it will have zero charge. So here this conducting sphere is not connected with battery. So charge will remain conserved. It will, initially it was having zero charge, finally also it will have what? It will have zero charge. Done. So first statement is what? Negative. Net charge on the sphere is negative and distributed uniformly over the surface of the sphere. No. Sphere पे net charge won't be negative. It will have net charge. Here it is asking about net charge. So net charge on the sphere will remain zero. Second is what? Negative and appears only. No, net charge is zero. So again, this statement is wrong. This is wrong. Negative, no, and zero. Yes, net charge will be what? So this is 10. That, like through every question, we have to pick all these small points and we have to keep it in our head and apply it in further questions, right? So let's now move on to the next question. Correct answer was D actually. So this is your next question. Now, what I want you to do is, I want you to read the question very carefully first, and then try solving it. You don't have to panic by looking at the question. You have to believe that you already know the things. Only thing is you have to read it carefully and do it. Done. So now your time starts. I'm giving you again 3 minutes of time here. Okay. So first you read the question carefully. Try to sink this question in your head and do it. If anyone is having any doubt, you can text me here on the Zoom also. and also on YouTube. Okay? Wherever you feel comfortable, you can text me. I will be answering. Okay? Let's do it. To read the question carefully, do it. I have given you 3 minutes of time. Please do it. Question solving is very important. Okay. So do it through questions. We will be learning concepts. We will be applying things later also. So what you have to do is you don't have to give up. That's all. So please do it. I will discuss also. But first, that thinking ability should develop inside you. That is very important because you have to write the paper, right? And you know more than me because you are a student. More 30 seconds, I will be waiting. After that, I will start with the process. Done. So, what we have to do is we have to read the question very carefully. Always, time and again, I'm saying this thing because this is very important. What the question is, there are 2 point charges minus q and plus q by u3, and they are placed in the xy plane at the origin. One is placed at the origin and another one is placed at a point 20. Another one is placed at a point 20. So coordinate of these 2 points are given. One is 0, 0, and another is what? This is your 20. And this is how much? 0, 0. Okay. So this is the coordinate. The result, this result, and because of placing of charges in such a manner, what is happening? This result in an equipotential circle. A equipotential circle is getting created of radius r and potential v equal to 0. Done. So on that equipotential circle, what is happening? What is the value of potential actually? Value of potential everywhere is what? 0. It is 0. Done. So v equal to 0 with its center at b0. और इसका सेंटर कहाँ है? b0 पे है. So suppose it's this circle is already denoted here. This dotted line is the equipotential circle, and its center is where? Its center is here, and its coordinate is given as what? b0. All lengths are measured in meter. The value of b is. So we have to say that value of b will be what? Done. So everything is given here. 2 charges minus q and plus q by 3. Where they are kept? One at 0, 0, another at 2, 0. Because of placement of charges in such manner, equipotential circle is getting created. And this circle center has coordinate of b0. I have to calculate, or we have to calculate value of b. Okay. So how we will do that? Now this is the question. So how we are going to do that? You just see here, potential at this point will be 0. Potential at this point will be 0. Every point on the circle will have potential equal to what? 0. Suppose I have coordinate of this point and I know the coordinate of this. So if I know the coordinate of these 2 points, I can easily calculate the value of its radius. Done. Because if coordinate of this is known, this is known, we can know the diameter. And if diameter is known, radius is known. And if radius or diameter is known, we can try calculating the value of B, right? So now let's calculate, let's assume that this point has a coordinate of some, let's say this is A0 and this is already B. So let's say coordinate of this point is how much? C0. So at A0 and at C0, our potential value because of these two charges is going to be what? 0. So now try to write the value of potential first at A0. So here value of potential will be what? It will be because of both charges minus Q and plus Q by 3, and their magnitude must be equal because here potential is equal to 0, and because of minus Q potential will be negative. Because of plus Q by 3 potential will be positive. So they are going to be equal and opposite. Again, potential is a scalar quantity, but opposite in sign. I mean, one will be positive, another will be negative. So let's write it. So potential at A0, what will be this? This I am going to do. So because of minus Q, it will be how much? KQ by how much will be this distance? If its coordinate is A0, so this distance will be how much? A. So KQ by A. And because of Q by root 3, what is going to be potential at A0? So we need to calculate this distance. What will be this distance? You can see here, this whole distance is how much? 2. This whole distance is how much? Its coordinate is given as what? B now. This point here, charge is kept here, right? 20. So at 20, charge is kept plus Q by root 3. And here we have to calculate the potential because of this. How much will be the distance? This whole distance is your 2 and this distance is A. So this small distance will be how much? 2 minus A. So that is going to be what? 2 minus A. So right here, KQ by root 3, 2 minus A. So this is our first equation, right? Now, from here, again, you have to solve. You will have to learn key questions are going to be lengthy and you have to solve it. So for that, stay prepared. Now A equal to how much? 2 root 3 minus root 3A. So root 3 plus 1A is equal to how much? This is going to be equal to 2 root 3. Done. This is going to be equal to 2 root 3. Now what will be the value of A? Value of A is going to be 2 root 3 by root 3 plus 1. So we have got the value of A. Now let's calculate the value of C. That we can also calculate similarly at C0. We will be writing potential because of minus Q and that because of plus Q by 3. And net value of potential is going to be what? That is going to be 0. So now we have to write the potential at which point? At this point. This point is how much? C0. So write the potential here. Because of minus Q charge, distance will be what? C. What will be the potential? Potential value is going to be KQ by C. And because of this charge, distance of this charge from this point is how much? This. How we can calculate this? We already know that this whole distance is C and this distance is how much? This distance is your 2. Done. So this distance will be how much? C minus 2. Now let's write the value of potential and equate them. Okay. So what will be the value? It will be KQ by C equal to how much we are going to get? KQ by C will be equal to KQ by root 3. KQ by root 3. Done. And what is the distance? Distance is our C minus 2. So this is the distance. Now KQ got cancelled. And what value we are going to get? Root 3C minus 2 root 3 equal to C. So what value we are going to get? Root 3 minus 1C is equal to how much? Is equal to 2 root 3. So C is going to be how much? 2 root 3 by root 3 minus 1. Now we have both the values. We know C and we know A. So if C and A is known, if you go back to the next slide and if I try to clean this diagram, you can see here if C and A are known, we can easily calculate what? we can easily calculate the diameter. So this is known, A value is known, and this is known, C value is known. So how much will be this value? This will be equal to C minus A. So we already know the diameter. So radius is going to be what? Radius is going to be C minus A by 2. So radius is known now. Done. So that thing you will be doing here, radius you will be calculating. And once you know the radius, now if you know the radius, how you can calculate the what? Now again, this is simply a geometry now. If you know radius, how you can calculate the coordinate of this point. So radius is known now. This value, suppose कर लो, this distance is x. Which distance? 2, 0 and B0 के बीच का distance is x. So if this is x and this is how much? 2. So 2 plus x plus, this is radius again, 2 plus x plus r will be equal to c. 2 plus x plus r will be equal to c. So you can calculate the value of x. And if you are able to calculate the value of x, we will be able to find the coordinate of B0. So the prime task was what? Prime task was to calculate the value of this coordinate and this coordinate. Once we are done with the radius, we can easily say what will be the coordinate of center. And that we have already done. Okay? So इस तरह से we have to solve the question. Question was very easy. Done. You simply need to write the potential. Question is damn easy. Very easy. But the only thing we have to keep in our mind is we have to keep patience. That is very important. So for next question, I want you all to think a lot and do the thing. This is the answer. You will be doing the geometry thing. I have told you the concept. I have solved much also. You just need to do subtraction and addition. This is the next question on your screen. Now I want you to solve it. Read the question carefully. I'm giving you 2 minutes of time. Okay. So I will be waiting for 2 minutes and you will be reading question carefully and seeing which one is correct and which one not. Done. Again, this is a single choice question. Done. If anyone has any doubt regarding the question, you can text me both here on Zoom and as well as on YouTube. You can comment, I can reply. Okay. Let's do it. Done. So I hope you all must have read it carefully. Now let's do it. What the question is, read the question carefully again. So a long hollow conducting cylinder is kept coaxially. The cylinder is hollow, it is conducting, and it is kept coaxially inside another long hollow conducting cylinder. So first you do what? You make a cylinder here, large one I have made first, and inside it is kept another cylinder again, and that is also hollow. Then, so smaller one is kept here. This is also hollow. Then, so this is the case. And then different things are happening. In option first, what it is said that a potential difference appears between two cylinders when a charge density is given to the inner cylinder. Suppose we are giving some charges to the inner cylinder. Sometimes you know what happens, we give so much thought that our question gets wrong. Then we have to make things simple as well. So यहाँ पे we are giving surface charge density to inner cylinder, nothing to outer cylinder. You just try drawing electric field lines. So electric field lines will look like this. Since this is a conductor, here it will end and then it will go out actually. Properly, let me draw. क्योंकि it should not go wrong. Done. Because that's conductor na, we can't do like that. So electric field in between the space I'm just drawing, it will look like this. Agree? It will look like this. Done. And if electric field exists in a space, if there is an electric field in the space, then what does it mean? In yesterday lecture only we have seen that in the direction of electric field, potential decreases the maximum. So if in space there is an electric field present, it means what? In this direction, potential is decreasing. So definitely potential difference is there between 2 points, right? So a potential difference appears between two cylinders when a charge density is given to the inner cylinders. True, right? A potential difference appears between the two cylinders when a charge density is given to the outer cylinder. Now let's say that we are not giving any charge to the inner cylinder, but we are giving charge to which cylinder? We are giving charge to the outer cylinder. What is going to happen in that case? This is our inner cylinder, and on outer cylinder we are giving a charge. So how you will draw the electric field lines? You just draw the electric field line. So it will look something like this if this is infinitely long. Otherwise there will be fringe effect. I've discussed yesterday. Done. So something like that. Now in this space, if you see, there is no electric field present. There is no electric field present. And if there is no electric field present, it means if you're going to use the formula dV equal to E dot dl, if E is 0, dV is going to be 0. There is no potential difference, right? It will be same throughout, constant. So this statement is what? Wrong. We should learn how to cut the statements, right? Now let's see the C. No potential difference appears between the two cylinder when a uniform line charge is kept along the axis of cylinder. अब देखो axis of cylinder पे you are keeping a uniform line charge, and if we are going to keep it like this, there will be electric field in this region. Definitely there will be. And if there is an electric field in the space, there will be potential difference. Same as first option, right? No, so no potential difference, no potential difference will be there. No potential difference appears between the two cylinder when same charge density is given to the both cylinder. So if we are giving charges to both the cylinder, there will be electric field in this space and so potential difference. Done. So if charge density is there at kept at the axis or on inner cylinder, then there will be electric field in the space between these two cylinders, so potential difference. Otherwise, not. So the correct option will be what? Only one. Okay? So I hope this is clear. So the correct answer will be what? A. Now we are going to solve third question, next question, and that is this. What I want you to do is, I want you to read the question very carefully. Again, do this. Read the question carefully and solve it. So I'm giving you some more 3 minutes of time, 3 or 4 minutes. Okay, do it. Please keep patience while reading the question, and also while believing that you can try. Okay, so give it a try. You need a little bit concept of SHM, simple harmonic motion. Done. Because here it is asked that, it is said that angular frequency is this. So what will be the value of delta here? I hope you have read the question carefully. Now, let me go through it. Okay. So, what the question is, one end of a spring, there is a spring here, you can see, and one end of a spring of negligible unstressed length means initially our spring is at natural length. Done. And the spring constant is given as K. It's fixed at the origin, and that is fixed at the origin. One end of natural spring, it's fixed at origin. Done. A point particle of mass m carrying a positive charge q is attached at its another end. Means there is a spring, it is fixed at this point. Done. And then a mass m is attached here. Then this is the question. And that m mass is carrying a charge q. Means this m mass is basically a charge particle and it has charge value q. The entire system is kept on a smooth horizontal surface. And this is kept on what? This is kept on a surface that is smooth. No friction is there. So if there is a friction available, there is no chance of SHM because its energy will die out gradually. But since here there is no friction, SHM can sustain. Then it can leave. Now the entire system is kept when a point dipole P pointing towards the charge Q is fixed at the origin. Now what is happening at origin? A dipole is placed. Then like this. So this is the dipole kept at origin. What is happening? What will happen because of the dipole? This is the first thing that you need to think. So if I'm keeping a dipole here just at origin, directed towards this axis, at this axis only. So what will happen if there is a dipole? You have studied that if there is a dipole like this, then it will generate electric field, and electric field along the axis, along any axial point used to be how much? 2 k dash मैं लिख रही हूँ क्योंकि यहाँ पे k already we have used for spring constant. So 2 k dash p by r cube, that is r is the distance of dipole and this point. Done. So this is r cube. So if it will generate electric field, and at equator also it generate electric field in this sense, then kp by r cube. So what will happen? This charge q will experience electric field in this direction. And since this is a positive charge, what is going to happen? If positive charge is experiencing an electric field, on that positive charge, force will act in the direction of electric field. So on this charge, force will act in this direction, in the direction of electric field. How much force? That force will be equal to Q into E. And because of this force, what is going to happen? This spring will get stressed. And as a spring will get stressed, a spring force will also come into action. And if a spring force is coming into action, that spring force will be in this direction because electric force is trying to stretch it, spring force will try to bring it back to its original position. So both the forces, electric force and a spring force, will be opposite in direction, and at a point it will become equal. And that is why यहाँ पे कहा गया है the spring gets stretched to a length L. कितने length पर वो, कितने length तक वो stretch हो रहा है? It is getting stretched to length L and attains a new equilibrium. क्योंकि initially this was the equilibrium state, no stretching. But because of dipole getting placed at the origin, force is acting. So definitely a new rest position of mass m is different. It will move by certain length such that electric force and spring force get equal. So new equilibrium position it is attaining. Now what is happening? From that new equilibrium position, what is happening? Point mass is now displaced slightly by delta L from its equilibrium position and released. Then what will be its oscillation frequency? So what you have to do now, you don't have to worry a lot ki yaar so much is written, how to solve it. Question is very simple. Question is, there is a spring initially attached to a mass m, and initially the system is at rest, equilibrium. What is happening? Then we are keeping a dipole. Because of dipole, what is happening? Because of dipole, a force will act, and because of that force, what is going to happen? New equilibrium position is coming. Done. So this question is same as you were having a spring at natural length. If you are giving it a mass m, it will get extended by certain length and then come at rest. That will be new equilibrium position. Done. So same as that. Now how to solve such question? So if you have to calculate the angular frequency of what? Any SHM motion, then first thing that you need to do is you need to either write the net force or you need to write the net energy. From both, you can easily calculate what? Omega. So here I will be using force, and later I will also discuss when to use energy wala thing. Okay? Later we will do that. So force likh lo aap at suppose this is the new equilibrium position, and from here I'm extending it by length delta L. So already how much extension was there? L extension was there, and after that we are giving it delta L extension and then releasing it, and then it is performing SHM. So net force will be what? Net force I will write as force of spring. Force of a spring, net force should act towards the center, है ना? क्योंकि net force should act opposite to the displacement, then only it will be SHM. So here a spring force is in this direction, so net force will be F spring minus F dipole. Done. So spring force value will be how much? K. Extension length, how much extension length is there? L plus delta L. Okay. Now what is the FD value? Force because of dipole value will be how much? So force because of dipole is going to be, write the electric field value 2K dash P by length ka value. How much length value is there? Means dipole distance from mass will be how much? Now initially it was L, and finally it will become how much? L plus delta L. So L plus delta L ka cube. Done. Now this is the equation, but we have studied that in SHM equations should come as what? Equation should look like A equal to minus omega square delta L here. Okay. So I should get something like this. So if delta L is in denominator, we need to reduce it in such a way that we get delta L in what? Not in denominator, but in numerator. How it is possible here? So if you look at the equation carefully, we can do it very easy. How we can do it? You just see here K L plus delta L, and here it is given that delta L is less than L. Delta L is very much less than L. So we can apply here binomial thing. And what is that binomial thing? If I take L as common, LQ, it will become 1 plus delta L by L. And we have studied in binomial in mathematics that if, again I'm going to write here, if 1 plus x power n then we can write as 1 plus nx when if x is far less than 1. So here you can see delta L is less than L. So 1 is what? Delta L by L is less than 1. Done. So that is very much less than 1 actually. So here we can apply this binomial wala thing. So let's do that now. So if we are going to apply that, what we are going to get, let's write it very carefully. So net force K L plus delta L and minus K dash P 2 K dash P Q divided by L Q. And here there was 1 plus delta L by L that we can write as 1 plus delta L by L ka power minus 3. So 1 plus nx, in 1 plus nx term we can put it. So let me do it directly here actually. So I'm going to write this thing here. So what it will become 1 minus 3 delta L by L. Now let's break it. So it will become KL plus K delta L minus 2 K dash PQ by LQ minus 2 K dash PQ by LQ into 3 delta L by L. Now see carefully, 2 K dash PQ by LQ is equal to what? So initial equilibrium position was what? After placement of dipole here at the origin, what the equilibrium position was? At equilibrium position, a spring was stretched to length L. So if a spring is stretched to length L and still it is at equilibrium, it means a spring force, that is KL, is equal to some other force, and that force here is what? Electric force. So that will be equal to 2 K dash PQ by RQ. Done. So 2 K dash PQ by RQ equal to what? KL. So that we can write here. So KL plus K delta L minus KL minus, again this is KL into 3 delta L by L. So if you see carefully, this will get cancelled out. L will get cancelled out, and what we are going to get? Sorry, this was minus. This was also minus. So this minus will become plus actually here. So how much we are going to get? We are going to get 4K delta L. This is the force, and this force is acting in this direction. So if I apply the sign carefully, this will have negative sign. If I'm going to put the vector sign, force is inversely, oppositely directed to displacement. So this is this. Now we can equate this force to what? SHM equation. So what you can write here? This is the answer actually. Here I'm going to do. So F value we got as what? Minus 4K delta L. F is written as what? MA minus 4K delta L. So acceleration will be equal to what? Minus 4K by M delta L. And the standard equation is what? A equal to minus omega square delta L. So what is the value of omega square here? That is equal to 4K by M. Done. So omega is how much? Root under 4K by M. And what will be the frequency? We already know that frequency equal to, omega is written as 2 pi F. So frequency equal to what? 2 pi by omega. So how much we are going to get? Omega equal to 2 pi F. This is wrong actually. F we have to calculate now. So what will be the value of F here? Omega by 2 pi. So how much is the omega here? Omega is root under 4K by M. So how much value we are going to get? We are going to get 2 outside. So it will become 1 by pi root under K by M. And in the question, it is given, frequency is given as 1 by lambda root under K by M. If you see the question, 1 by lambda root under K by M. So what will be the value of lambda here? That will be pi. Yani ki that will be 3.14. Okay. Now let's do another question. Okay. Take deep breaths. Read the question carefully. Again, here you don't have to do the calculation. So read the question carefully and do it. I'm giving you another 2 minutes. Okay. I'm giving you 2 minutes, but it deserves only 1.5 minutes. Anyway, do it. I hope it is done. Question is very easy actually. So what is the question first? Shown in the figure is a cell made of a conductor. It is a conductor. It has inner radius A and outer radius B and carry charge Q. At its center is a dipole P as shown. In this case, what will happen? So there is a plus charge here. This is a dipole now, so this will be minus and this will be plus because direction of dipole is from negative to positive. So this is like this. First, let's see what is going to happen. So this is a conductor. It will have free charges. This positive charge will attract the negative charges here, and this negative charge will attract the positive charges here. Then this is going to happen. Now, just think carefully. Will there be any charge on the outer surface of the conductor? This is a question here. So I have told you before as well, if there is a conductor and we are giving it charge Q, then all the charge will appear on the surface. Then similarly, we are giving this conductor a dipole. So all the charge of dipole will appear on its outer surface. And charge of dipole is equal to what? Net charge on the dipole is what? Zero. So there is no charge going to appear on the outer surface. Again, on the inner surface also, total value of charge getting accumulated will be zero only. Here negative, here positive, and both will be, both when added will become equal to what? Zero. Done. So this question is C, very simple, damn simple. So surface charge density on the inner surface is uniform. On the inner surface charge density is not uniform. On this surface, it is negative, here it is positive, and also this positive charge is more close to this negative surface, this surface. So here negative charge will be more crowded, and here it will be less crowded. So not uniform. This is wrong. Now, electric field outside the cell is same as that of a point charge at the center of cell. So there was also a charge Q actually on the outer surface initially present, plus Q charge hai. Because of dipole, there will be no charge appearing on the surface. So statement B is what? Electric field outside the cell is same as that of a point charge at the center of cell. So we have already studied that if there is a cell, we are giving a charge Q, all the charge will appear on the surface. And for cell, we have studied that electric field inside is zero, on the surface is kq by r, and outside it is kq by r squared. Here also what is happening? Dipole is given to the cavity. So net charge because of dipole on the surface is zero. And already there was plus q charge present. So outside this configuration, electric field value will be what? kq by r squared. Done. So this is same as q charge is kept at this point. Done. So B statement seems correct. Now see, surface charge density on the outer surface depends on P. On the outer surface charge density will not depend on P because the total charge contained in P is what? Zero. So if we are giving dipole to any conductor, then what will happen? Total charge appearing on the surface will be equal to charge of dipole, and charge of dipole used to be equal to zero. So this is wrong. Now surface charge density on the inner surface of the cell is zero everywhere. So inner surface of the cell पे हर जगह क्या charge density zero है? No. Here the charge density is something positive. Here the charge density is something negative. Overall, when added, charge is becoming zero. But at this point, there is some charge density. So this statement is also what? Wrong. Only correct statement is what? B. So this question is very simple. Again. Now we have another question that is again from SHM. Just remember that from SHM you will be getting questions, but you don't have to panic. You have to simply remember the basic of SHM. You don't have to dive deep into SHM ki yahan pe kya kya ho raha hai, not so much. Only you need the basics. So what I want you to do is, I want you to read the question very carefully with all love and care. Do read it, and after that, just believe that you can try it, give a try. Even if it is not happening, not an issue. But yes, if you are giving it a try, you are actually giving thought to the question, and that will gradually build up in your mind a knowledge. Done. So that is very important. Do it now. I'm giving you another 3 minutes. Done. So I hope you must have tried it. Now let's try it together. So what the question is a particle of mass 10 to the power minus 3 kg and charge how much? Charge is your 1 coulomb is initially at rest. So initially that is at what? Rest. Done. So let's take a charge Q here, and its value is 1 coulomb, and its mass is how much? 10 to the power minus 3 kg. So initially it is at what? Rest. Now what is happening? Particle comes under the influence of an electric field, and electric field is function of sine. Done. So that is E naught sine omega t. E naught value is given, omega is given. Consider the effect of only the electrical force on the particle. Done. Only electrical force we have to assume. Then maximum speed attained by the particle at subsequent time is. So what will be the maximum speed attained by the particle? This is the question. So first we need to see very carefully that there is a charge initially at rest, electric field is acting on it. So definitely in the direction of electric field, force will act on this particle, and that force will act as what? Q into E. E value is how much? In Q E naught sine omega t. So the force that is acting is function of sine. And we have studied in our simple harmonic motion. For any motion to be simple harmonic, what is the condition? In nutshell, we write that acceleration must be equal to minus omega square x. Done. And this is true. This happens if our displacement or velocity or acceleration, yeah, force कह सकते हो, is function of sine or cos. So if your displacement, velocity, acceleration, or force is given as a function of sine or cos, then definitely that thing is going to perform SHM. If it is kept in an environment where there is no friction kind of force is available. So here no friction kind of force is there, and force acting on the particle is function of sine. So definitely this particle is going to perform what? SHM. And in SHM, we have studied what we have studied in SHM, if you remember carefully. So if I'm going to draw this line, call it mean position, okay? And this as extreme position, this as extreme position. So we have studied that at mean position, velocity used to be maximum. Done. Velocity used to be maximum. Here velocity used to be 0. Here velocity used to be 0. Done. So for maximum, and at maximum velocity happens at mean position, and also at mean position, force used to be what? 0. Done. You just imagine the spring. So in case of a spring, what happens? This is your spring. Mean position means at the point where when our spring is at its natural length. So if a spring is at its natural length, definitely force will be 0. And at extreme position means a spring is maximum extended. So definitely at that point, force will be maximum. At next extreme position means a spring is maximum compressed. Again, force will be maximum. But at mean position, force is going to be equal to 0. And at this point, velocity will also be 0. Sorry, maximum. So at mean position, kinetic energy will be maximum because velocity is maximum, extension is 0, x is 0, yani ki force is 0. It means potential energy is also 0, that is half kx square. And at extreme position, kinetic energy will be 0 because velocity is 0, force will be maximum, extension is maximum, or compression is maximum. It means potential energy is maximum. But in SHM, we have studied total energy used to be constant. So here in this question, which part we are going to apply, which information we are going to use, and that information is at maximum velocity, force will be 0. Done. So let's now do it. See, question will be very easy. Question is again not tough. Let me tell you. Question is very easy if you really know a basic of what? SHM. So you just need to know the basic. जैसे यहाँ पे जैसे ही आपको force दिखाना, a thing would click in your head कि यार force is a function of sine, so definitely it will be SHM. And if it is SHM and they are asking about maximum speed, it means it will happen at the mean position at the point where force is 0. So equate force to 0. So here force is QE. So Q into E naught sine omega t will be 0 when velocity is maximum. So this can't be 0. Sine need to be 0. Done. Sine will be 0 when omega t is equal to pi. Done. So at maximum velocity, when maximum velocity will happen at t equal to pi by omega. Done. So this is the max. This is the time when we are going to get maximum velocity. Now we have to calculate it. How we will calculate it? So calculation, again we have force. So for force we can calculate what acceleration, and from there we can calculate what velocity. So let's do that here now. So now that thing I'm going to do. This is the answer basically. So let me do that here. So what we have got force equal to what? Q E naught sine omega t. Force can be written as what? Mass into acceleration. That is Q E naught sine omega t. Again, acceleration can be written as Q E naught by m sine omega t. Now you can break, because we need velocity now. So A can be written as dv by dt. Q E naught by m sine omega t. Now what will be the value? Dv we can integrate, and similarly q e naught by m is constant, take it outside. So sine omega t dt. Again time will vary from 0 से pi by omega, क्योंकि at pi by omega we are getting maximum velocity. Initially it is at rest t equal to 0 पे, this is at rest, so velocity is 0, final velocity is something v at t equal to pi by omega. So if we are going to integrate it, what we are going to get here? Just tell me what we are going to get here. So we are going to get here v, and this v will be equal to q e naught by m. What is the integration of sine omega t? This is minus cos omega t by omega. Done. So here it will be omega minus sine cos omega t, and this will vary from 0 say pi by omega. If you're going to put the value of integration, value of lower and upper limits, what you're going to get? V equal to minus q e naught by m. You just put the values. If you're going to put t equal to pi by omega, it will become cos pi minus cos 0. This is, so v equal to minus q naught by m into cos pi minus 1 minus cos 0 1. So minus 1 is how much? Minus 2. Minus minus will become plus. So velocity is how much? 2q e naught by m. Now put the values. So 2q ka value was given as 1 coulomb. E naught value was how much? E naught was 1. E naught is 1. Q is 1. Mass is 10 to the power minus 3. Omega is 10 to the power 3. Sorry, here there was omega, right? So, done. So we have to put 2q E naught is 1. Mass is how much? 10 to the power minus 3. Omega is how much? 10 to the power 3. So velocity value we are going to get as what? Velocity value we are going to get as 2 meter per second. That's the answer. Okay? So we have already got that. Now let's move on to the next question, and please try doing it. Again, take 2 minutes to, or first read the question carefully. I'm giving you 3 minutes for now. Do it. Read the question carefully and try doing it. Read the paragraph, and what I want you to do is please draw this diagram on your copy and then read the question carefully, because this is a paragraph type question. There will be 2 or more question tagged with it. First question is there on the screen. There are 2 more questions. So I want you to draw the diagram on your copy. Don't write the question. Simply read the question and then move ahead with the solution. Okay. So take your time. I hope you have read it and you must have tried it. Done. So now let's do it together. So what the question is, nuclear charge is non-uniformly distributed within a nucleus of radius r. So this is a nucleus and its radius given is r. Done. Charge is uniformly distributed. The charge density rho r changes per unit volume is dependent only on the radial distance r from the center of nucleus as shown in the figure. The electric field is only along the radial direction. Means electric field is something given like this. Okay? Only along the radial direction. And charge is non-uniformly distributed and rho is distributed like this. It is given in the graph. So you can see from the graph that if this is our radius, sorry, nucleus, then from center to certain distance r, sorry, certain distance a. In this region, charge density is what? Constant. That is equal to T. And from A to R, what is happening? From A to R, charge density is something like, okay, this is given. Now the very first question is electric field at R equal to R. See, I'm telling you again, questions often comes from the application of Gauss's law, from that SHM combination wala thing. And third thing is that distribution of charge around conductors and all. Okay, these three topics are hotly contested, I must say. Questions are coming from these posts, right? So here we have to be very careful while applying Gauss law. Okay. Careful what means if we know the logic, we can do it very easy. So first thing is electric field it is asking at R equal to R. You just see this was my nucleus and at this point electric field is asked. And it is said that electric field is always radially outward. Done. So if electric field is radially outward, our question gets more easy. Done. So what we can apply? We can apply Gauss's law. How? E dot ds equal to what? Q enclosed by epsilon. So suppose this is the Gaussian surface I have drawn passing through the point P at which I have to calculate the electric field. So here area vector will be what? Radially outward. Then electric field is also radially outward. So angle between E and ds is what? 0 degree. So here we can write E ds cos 0, that is 1, equal to Q enclosed. How much charge is inside this nucleus? Total charge. We don't need to worry about how charge is distributed. We just have to say what is the total charge. So that is ZE by epsilon naught. Again, electric field at all this point will be what? Constant. Done, because they are symmetrically around the charge distribution. So E is constant. ऐसे भी हमने पढ़ा है solid sphere and hollow spheres, like at any radial point. Suppose there are certain 1,000 points at radius r or at distance r, then at all those 1,000 points, electric field and potential will be what? Constant. So E is here constant, ds equal to ZE by epsilon naught. So here you can see ds will be equal to what? 4 pi r square, E into 4 pi r square, ZE by epsilon. So here you can see electric field is not at all independent, not at all dependent on A. Done. So the answer will be what? Answer will be because electric field at R equal to R has nothing to do with the charge distribution. It has to simply do with how much charge is inside. Done, and that is ZD. Clear? Now these are two questions again. Tag with it. I want you to again do these two questions. Take 5 minutes of your time, okay, and do it. But be very wise while doing the calculation. Okay. So do it. Questions like passage is given here. I know. So you already have drawn the diagram. Done. And that is a nucleus of charge, ZD total. Clear? So by looking at the diagram, you can do it. For A equal to 0, A को 0 लेना है, then we have to tell the value of T. D का वैल्यू क्या होगा? Take your time and do these two questions. Okay. Don't worry, I'm present here only. If you have any doubt, you can text me. You can ask, you can talk, you can communicate, and most importantly, to solve the question. Okay. So I hope you all must have tried it or even got some answers as well. So let's do it now. What the question was, 122 question I'm dealing with. For A equal to 0, value of D. What it is asking? It is asking the value of D. From this graph, D was what? The value of what? Value of charge density from 0 to A. Done. So we have to calculate T somehow. How we will be able to do it? Done. Now this is the question. Suppose here I am drawing the diagram of charge density. Okay. So here it is rho r here it was radius given. Done. So what was the graph? Graph was something like this. Done. And this value was how much? D. And this value was how much? A. And this was how much? R. That was your radius of the nucleus. Now, so what logic we can use here actually? So if somehow you try to calculate charge contained inside nucleus by using the charge density, because charge inside nucleus we already know that is equal to total charge inside nucleus is how much? Jd. And if in term of rho, we are trying to calculate Jd, like Q can be written as na rho R into 4 by 3 pi r cube. Like that we can write here. Directly we can't because rho r is not a constant. For some distance it was constant and then it is linearly changing, right? So we can calculate Q by this method also, and we can equate these two. From here we can get the value of what? We can get the value of D. Done. So you have to keep patience actually. Patience. That is very much important. For starting few days you will be struggling. After that things will get easier because after that you will get habituated. So habit बहुत बड़ी चीज होती है ना? So let's do it now. So first I'm going to write the value of rho r. How rho r will look like? How to write rho r here? So if I'm going to write it, just see here. This is from A to R. Just see rho. Suppose here the value of rho r is how much? Some rho x it is. Let me make it more bigger actually. So let me do it like this. So it was something like this, right? So here, suppose the value is x. Distance from the center is x, and here the density is rho x. Done. And here value was how much? Here the value was x was a and y was b, and here the value was how much? Is how much? R and 0. So if we are going to write the slope of this charge, or this graph or rho we are going to write, then how we will write it? Means simply you have to write the equation. So if you can write the equation from here, what you will do? Rho x minus d, simple mathematics करना है, कुछ भी नहीं करना. Rho x minus d divided by what you will write? X minus a. This can be the slope. Also slope can be written as 0 minus d divided by r minus a. So equal to 0 minus d divided by r minus a. So this is the slope of this line that we can write in this ways. I have equated these two. Now you just see here, in the question a is given as equal to 0. So equate a to 0. Now rho x will become what? Rho x minus d divided by x, because a is becoming 0. A is becoming 0, so this was 0 actually. 0 minus d, so that is minus d divided by r. So rho as a function of x can be written as what? It can be written as minus d by rx plus d. Done. So if rho x we know as a function of x, we can calculate charge. How we can calculate charge? You just see here. This is the answer actually. So Q, this was nucleus, right? And if I have to calculate charge contained in this, let me make it more clear. I'm bad in diagram. So this was nucleus. Suppose I have to calculate charge in this small region of thickness dx. So volume of this region will be how much? Its area into its thickness. So its area will be how much if this distance is x? Area, yani ki volume I'm going to write. So that will be dx into area, 4 pi x square. So what will be charge in this region? So charge contained in this region will be how much? Charge density rho x into 4 pi x square dx. So total charge will be what? X will vary from 0 to 1. That we have to do, right? So from here, Q equal to how much? Rho x का value आप put कर दो. रो एक्स का वैल्यू हमारा कितना आया था, माइनस डी बाई आर एक्स प्लस डी. So this is minus d by r x plus d. This is rho x into 4 pi x square dx. 0 to r. Q ka value is how much? That is jd. Now simply what you do? Integrate it. So minus d 4 pi d minus 4 pi d r x q dx. So x q dx is x4 by 4. Now plus 4 pi x square d dx. So 4 pi d take as common, x square dx will become x cube by 3. This is from 0 to r. So now find its value. So this will become minus 4 pi d r r4 by 4. So this 1r will get cancelled. So this is r cube plus how much? 4 pi d x cube means r cube by 3. Now solve this two. If you're going to solve this two, what value you are going to get? ZE equal to how much? ZE equal to 4 pi d r cube common le lo, 1 by 3 minus 1 by 4. And this will be equal to how much? 1 by 12. So 4 by 12 pi d r cube. So this is 3. Now this is becoming 3ZE equal to pi d r cube. Now what will be the value of t? 3ZE by pi r cube. Done? So this way we are getting the value of what? We are getting the value of t. 3ZE pi r cube. So this is the correct answer. Now question number 123. जैसे इस passage में there were 3 questions. 2 questions were like you just need to look at it and tick it. Only in question number 122 you needed to do some bit of calculation. How? Just say 123, you look at this question. The electric field within the nucleus is generally observed to be linearly dependent on R. This implies. So we have studied in, just a nucleus is what? Nucleus is like a solid sphere, right? Non-conducting solid sphere kind of configuration it is having. And we have studied that in non-conducting solid sphere, electric field used to be like rho r by 3 epsilon naught. Then electric field used to be directly proportional to r. And there, this rho was constant actually. Done. So here what is saying, the electric field within the nucleus is generally absorbed to be linearly dependent on r. So the question is saying that E is linearly dependent on r. So what can we say about A? So if E is directly proportional to R, it means rho is going to be constant. And rho constant ka matlab kya? Just come to the diagram. Rho is constant throughout if E is directly proportional to R. But here you can see rho was constant only up to distance A. And after that it was linearly changing. Done. So for rho to be constant, A must be equal to R. A must be equal to R. Then only who will be constant throughout. Done. So rho is constant means what? We will see in which region rho is constant. So rho is constant from 0 to A. So this A must be equal to R. Done. So the correct option for 123 should be what? C. Are you getting me? Like this is nucleus like a non-conducting solid sphere. In non-conducting solid sphere, electric field is directly proportional to R. And in that case, rho used to be constant. Yani ki throughout nucleus, charge is uniformly distributed, constantly distributed. Done. And this is only possible according to the diagram if A is equal to R. Done. So this was our thing. Now I hope things are clear. I have added question ahead. Again, this is also a question from your Gauss's law. Again, very simple question it is. You just need to read. And this question is also, I needed to discuss some 2-3 questions more. Tomorrow I will be doing that together with some question from capacitance. Okay. So I will be sharing question for you to solve. You can solve it and let me know what doubts you're having. Okay. So bye-bye. Take care. Stay safe. And safe means keep your mind healthy. Keep working. Don't take pressure. Don't take tension. Enjoy. Chalo.